National Electrical Code Section 314.17 addresses conductors entering boxes, conduit bodies, or fittings. Specifically, 314.17d focuses on conductors that are 4 American wide gauge or larger. This section mandates that the installation of these larger conductors must comply with Section 300.4f of the National Electrical Code. Section 300.4f pertains to the protection of conductors from abrasion where they enter enclosures. The requirement is to ensure that conductors are not damaged or abraded as they pass through the entry points of boxes, conduit bodies, or fittings. Abrasion can compromise the insulation of the conductors, leading to short circuits, ground faults, and potentially hazardous conditions. Section 300.4f provides specific guidelines on how to protect conductors from abrasion. These guidelines typically involve the use of bushings, sleeves, or other protective devices at the entry points of enclosures. Bushings are insulating components that are inserted into the openings of boxes or fittings to provide a smooth, rounded surface for the conductors to pass through. Sleeves are tubular coverings that are placed over the conductors to provide an extra layer of protection against abrasion. The selection of the appropriate protective device depends on the size and type of conductor, as well as the specific requirements of the installation. It is important to carefully inspect the entry points of enclosures for any sharp edges or burrs that could damage the conductors. Any such imperfections should be removed or smoothed out before the conductors are installed. In addition to using protective devices, it is also important to ensure that the conductors are properly supported and secured within the enclosure. This will help to prevent them from moving or vibrating, which could also lead to abrasion. When installing conductors for American wire gauge or larger, it is essential to carefully follow the requirements of both 314.17d and 300.4f to ensure a safe and reliable electrical installation. Failure to comply with these requirements could result in electrical hazards and code violations. The purpose of 314.17 is to ensure that conductors entering electrical boxes, conduit bodies, or fittings are adequately protected from physical damage, particularly abrasion. This protection is crucial for maintaining the integrity of the electrical system and preventing potential hazards. Now let's delve deeper into the specific requirements outlined in 314.17 and its subsections. Section 314.17 through D provides detailed instructions on how to properly protect conductors based on their size and installation methods. Subsection A typically addresses conductors smaller than 4 American wire gauge, specifying methods such as using cable clamps, bushings, or other approved fittings to secure and protect the conductors as they enter the enclosure. These methods prevent the conductors from being damaged by sharp edges or movement within the box. Subsection B might cover specific requirements for non-metallic boxes, detailing the types of fittings or adapters that must be used to ensure a secure and insulated connection. Non-metallic boxes require special attention to maintain their non-conductive properties and prevent any potential electrical hazards. Subsection C could address the use of conduit and the requirements for proper conduit connections to boxes and fittings. This includes ensuring that the conduit is securely fastened and that any necessary bushings or lock nuts are installed to protect the conductors from abrasion at the conduit termination point. Now focusing on subsection D, which is directly relevant to the question, it specifically addresses conductors that are 4 American wire gauge or larger. For these larger conductors, 314.17d mandates compliance with 300.4f. This cross-reference is critical because 300.4f provides detailed requirements for protecting conductors from abrasion as they enter enclosures. Section 300.4, in general, deals with the protection of conductors from physical damage. Subsection F, specifically, focuses on the protection of conductors entering enclosures. It typically requires the use of bushings, sleeves, or other approved means to protect the conductors from abrasion at the point of entry. Bushings are insulating devices that are inserted into the knockout holes of electrical boxes or fittings. They provide a smooth, rounded surface that prevents the sharp edges of the metal enclosure from damaging the conductor's insulation. Different types of bushings are available, including plastic bushings, metal bushings with insulated throats, and grounding bushings. The choice of bushing depends on the size and type of conductor, as well as the specific requirements of the installation. Sleeves are another method of protecting conductors from abrasion. These are typically short lengths of insulating tubing that are slipped over the conductor at the point where it enters the enclosure. Sleeves provide an extra layer of protection against sharp edges and physical damage. In addition to bushings and sleeves, other approved methods may include the use of cable clamps with smooth, rounded edges, or the application of insulating tape to the conductors at the point of entry. The key is to ensure that the conductors are adequately protected from any potential abrasion that could compromise their insulation. It is important to note that the requirements of 300.4F may vary depending on the specific edition of the National Electrical Code that is in effect. Therefore, it is always essential to consult the latest version of the code to ensure compliance. Furthermore, local electrical codes may have additional requirements or amendments that must be followed. These local codes may be more stringent than the National Electrical Code, so it is crucial to be aware of and comply with all applicable regulations. When installing conductors for American wire gauge or larger, it is also important to consider the bending radius of the conductors. Larger conductors require a larger bending radius to avoid damaging the conductor or its insulation. The National Electrical Code provides guidelines for minimum bending radii based on the size and type of conductor. These guidelines must be followed to ensure that the conductors are not stressed or damaged during installation. In addition to the bending radius, it is also important to properly support and secure the conductors within the enclosure. This will prevent the conductors from moving or vibrating, which could lead to abrasion or other physical damage. Cable ties, clamps, or other approved means can be used to secure the conductors to the inside of the enclosure. When working with large conductors, it is also important to use the proper tools and equipment. This includes using cable cutters or saws designed for cutting large conductors, as well as using cable benders to properly bend the conductors without damaging them. It is also important to wear appropriate personal protective equipment, such as gloves and eye protection, to prevent injury. In summary, National Electrical Code Section 314.17d requires that conductors for American wire gauge or larger comply with 300.4F when entering boxes, conduit bodies, or fittings. This means that the conductors must be protected from abrasion using bushings, sleeves, or other approved means. It is essential to consult the latest version of the National Electrical Code and any applicable local codes to ensure compliance. By following these requirements, you can ensure a safe and reliable electrical installation. Now let us also consider some potential scenarios when these guidelines are applicable. Firstly, in industrial settings, large conductors are commonly used to supply power to heavy machinery, equipment, and distribution panels. When these conductors enter junction boxes or control panels, it's crucial to protect them from abrasion to prevent insulation damage and potential short circuits. Secondly, in commercial buildings, large conductors are often used for main power feeders and distribution systems. These conductors may pass through various enclosures and fittings, making abrasion protection essential for long-term reliability and safety. Thirdly, in residential applications, while less frequent, large conductors may be used for subpanels or high-demand appliances like electric vehicle chargers. Ensuring proper protection at the point of entry into electrical boxes is vital to maintain the integrity of the electrical system. Here are some practical tips for ensuring compliance. 1. Always inspect the entry points of enclosures for sharp edges or burrs before installing conductors. Smooth out any imperfections to prevent abrasion. 2. Use appropriately sized bushings or sleeves that are specifically designed for the conductor size and type. 3. Ensure that the conductors are properly supported and secured within the enclosure to prevent movement and vibration. 4. When bending large conductors, adhere to the minimum bending radius requirements specified in the National Electrical Code. 5. Use proper tools and equipment for cutting, stripping, and terminating large conductors. 6. Always consult the latest edition of the National Electrical Code and local electrical codes for the most up-to-date requirements. Let's talk about the consequences of non-compliance. Firstly, installation damage can lead to short circuits, ground faults, and potential electrical fires. Secondly, equipment malfunction can occur because of damaged conductors, leading to downtime and costly repairs. Thirdly, electrical shock hazards can be present, posing a significant risk to personnel. Fourthly, code violations can result in fines, penalties, and potential legal liabilities. Fifthly, increased maintenance costs are a common result due to the need for frequent inspections and repairs. When selecting the right materials, consider the following. Firstly, use bushings made of durable materials such as nylon or phenolic resin, which provide excellent abrasion resistance. Secondly, opt for sleeves made of heat-shrinkable tubing or other insulating materials that offer reliable protection. Thirdly, use cable clamps and connectors that are specifically designed for the size and type of conductor being used. Some common mistakes to avoid include firstly, neglecting to use bushings or sleeves at all, assuming that the conductors are adequately protected. Secondly, using undersized or incompatible bushings or sleeves that do not provide sufficient protection. Thirdly, failing to properly support and secure the conductors within the enclosure. Fourthly, ignoring the minimum bending radius requirements when bending large conductors. Fifthly, neglecting to inspect the entry points of enclosures for sharp edges or burrs. Finally, remember, compliance with National Electrical Code Section 314.17d and 300.4f is not just a matter of following the rules. It is a critical aspect of ensuring the safety and reliability of electrical installations. By understanding the requirements and following best practices, electrical professionals and installers can minimize the risk of electrical hazards and ensure a safe working environment.